Hello, everybody, and welcome to the very first episode of Constellation, our new stream from Qualcomm, where I, Sascha Segan from Qualcomm, will talk to various stars in our constellation of partners. We at Qualcomm are a partnership company. We don't succeed without the amazing people we work with, and so I'm really thrilled to be spotlighting several of these amazing people over the upcoming year. I'm especially thrilled that our first guest is Aleyner, the head of tech alliances at Docker, a company that developers nowadays, I think, almost universally can't do without. Ellie, thanks for coming on.
Excited to be here. Excited to
Great.
chat to you today.
Great. Okay, so for the, in case there is someone watching this who doesn't know what Docker is, and I can't imagine that there's a developer who doesn't know what Docker is, can you give the quick précis on what Docker does?
Docker is a original container company that allows developers to ship software to production in the most efficient way. Docker started over a decade ago and really pioneered the way to ship software in the DevOps revolution. In the new days, Docker is extending that into AI workflows and extending what we do from just containers and DevOps to how you ship AI applications to production. So excited to be here and talk a little bit more about that.
Great. And one thing I wanted to get clear, just because I think it's the number one FAQ about the way Docker works, containers are not virtual machines, right?
Containers are not virtual machines. There are some similarities, but they're much lighter weight. They are a packaging format. They have a number of differences with virtual machines. Start much faster, much more portable, have a full ecosystem.
So lightweight, fast, that of course goes to a lot of our own selling points around Windows on Snapdragon devices. And you guys have recently kind of ramped up your Windows on Snapdragon support, right?
Correct. So Windows on Snapdragon is an important market for us. We've released initial beta support about a year ago, and then just a few months, actually at Microsoft Build, months ago, we went into an early access program, which means that we are now, it's early release that we're in, which basically means that we have full production support for Docker on Snapdragon X devices, and it's an important area for us, and it's an important to continue innovating. And we're seeing lots of customers who are coming and asking for this. So we're excited to partner with Qualcomm and excited to continue to build.
Great. Now, there's a lot of terms that go around in software release schedules like this. Like there's beta, there's early access, there's early release, there's release. I'm always a little confused by that early access phase. Exactly what does that mean that you have and you don't have at that point?
So in our case, you have full production support in that case. So we are happy for people to use it for production use cases. What we don't have is we still believe that there might be some hiccups. So we're not yet fully calling it full production. But we are the same SLA that applies to production releases applies to Docker on Snapdragon X devices at this point.
Great. And now this is a relatively new.
Sorry, just full functionality. Everything is supported. It's full production Docker. It's just the moniker that's a little bit different right now.
Okay, I mean, Gmail was in beta for 15 years. So.
I've heard, yes.
Yes.
We're going to try to keep it much shorter than.
So Snapdragon, so Windows on Snapdragon's a relatively new platform. Are you getting feedback from the early users yet? What kinds of features are people asking for? What kinds of things are they using Docker for at this point?
So Docker is a universal tool. Docker is used for lots of different things. What we're seeing on Snapdragon in particular is we're seeing people playing a little bit more with AI capabilities. So some of the new Docker model runner capabilities that we've released, the ability to run LLM models as containers. What we're seeing in general, people starting their journey, people starting to build applications. They want to build applications that work locally on their machine. They like the ability to run locally and then be able to use the same tooling to ship those applications to their CI/CD and to production. In our case, we're seeing a lot of interest in Docker Model Runner and ability to integrate LLM models as part of your application. We're seeing a slight skewing towards that on Snapdragon X devices because our assumption is that many of the developers buying those machines are interested in this space, and we're excited to see it.
Okay, so I want to dig into on-device AI, obviously, because you mentioned on-device AI at the very beginning, but in the most recent answer, you're focused on LLMs. And one of the things I want to break apart here is in the Windows developer world, does on-device AI mean LLMs, or are there other uses for on-device AI that we're seeing already?
There's lots of different uses. In our particular case, we're seeing a lot more LLMs being used simply because it's the newest, hottest thing and developers are trying to play around with it. And we believe that we have one of the easiest ways to get to use it and then still be able to ship those features and those artifacts down the line into CI/CD production environments and so on and so for that. So for us, we see a strong correlation. In reality, it's of course LLMs does not equal AI, and it's a much bigger ecosystem. And you know, AI developers have been using Docker for much longer than this current wave has been around.
So, there's this constant proliferation of LLM related applications on the web, but a lot of them just seem to be, oh, I just vibe coded a front end to a OpenAI API, and that seems so easy for a lot of people to do. Why are people bringing it on device? Why are people doing the work to run an LLM on their device as opposed to vibe coding a front end to an OpenAI API?
I don't think that those are mutually exclusive, to be honest. Right? I sometimes wipe code. I have to admit, nobody is perfect. I do it sometimes as well. But to be honest, look, there's lots of different use cases that exist in this space, right? So you can be white coding. You could be using the cutting edge, the frontier model for lots of use cases in your application. But in reality, when people start looking at this, number one, the open source models are continuously improving, and the latest releases are actually doing amazing work where you're able to run them either locally, you're able to run them on device, you're able to run them also in production. You're able, by running on device or by running in your own capabilities, you're able to control the amount of information that is going through the wire. You're able to control, people do it for privacy, people do it for those kind of use cases. You're also seeing lots of use cases where people say, hey, look, I'm going to use a frontier model for some of the advanced queries, but I'm also going to use, if I need to summarize 5 fields into a single field, I don't need the frontier model in order to be able to do that. I'm actually going to use a smaller model, a much more compact, and a model that I can deploy locally in order to handle those types of use cases. We see quite a bit of a distribution as it goes from people who need frontier for some use cases and sometimes pre-processing of information before it goes into the frontier, sometimes post-processing what you get back, sometimes doing testing. So lots of different use cases where smaller models make a lot of sense and where you can get amazing results using smaller models. Also for, just I don't necessarily always want to send all my data to OpenAI or another company based in the US, especially given the geopolitical climate.
That's a really good point. I mean, you mentioned the geopolitical climate. I was thinking myself of, the price of credits and how, all of these frontier models, cloud services, you're paying to use them. So if you are doing AI processing, how much can you take off of that burden so that you're spending your credits on what you really need to spend them on?
100%. Talking to lots of developers, that is a concern. There is also concern in some ways you don't control the model. You can be optimizing your prompts for a particular model, and that model could disappear, right? So
Yeah.
having a little bit more control over that is also an important element for many developers, right? If you fine tune what you're doing for a specific model, how can you have control over the model that you're using?
Do you think development has, at this exact moment, swung too far towards the cloud? Are we going to see a bit of a pendulum back towards more local development? I feel like everything has been. I can say this because I'm not meaning it in the rude way. Everything has been ass recently, by which I mean as a service.
Yeah. Funny. I honestly think that there is a spectrum of things. To be frank, I think that there's various ways of looking at this. Like whether you're gonna like, I think that on-device computing has always been a big element of development workflows. As a developer, I want to be able to run locally. I need the speed. I need the ability to control things, right? I need to have my own environment. This is in a lot of ways why Docker is being used. On our side, we're also seeing a bit of adoption of what we're calling remocal tools. So tools that feel like local but might be running remote. So we've recently announced Docker Offload, the ability to get expendable compute resources out in the cloud. So those types of use cases. But generally, on device is something that is very core to developers to use. And as more and more tools become available, developers still want the ability to work on a plane when they are going somewhere, or in a coffee shop where the Wi-Fi might be spotty. So while we see cloud and we see remocal tools, we also want to make sure that those capabilities can continue working when you're working on a device.
So you're kind of so what the viewers may not know is you're kind of one of the architects of the world we live in now, in that you were no, I would say so, because you're one of the people who helped found AWS, right?
I was an early engineer. I was an
Okay.
early engineer at AWS. So are the core leaders of Docker right now. So I happen to have been working at AWS back in the day with our current CEO, our current president of the company, the head of engineering. All of us come from AWS from the early days.
So what was the problem that you guys felt you were solving then? And do you feel like that problem is solved now? And has it created any other problems that you didn't foresee?
Good question. At the time, when we were at AWS, what was clear to us is the way the core internet scale companies are building applications is drastically different from everybody else. What was clear to us back in the day is that commodity compute, or commodity hardware, so to speak, is a new architecture. And in reality, only a handful of companies around the world at that particular point were able to produce systems that could run on commodity hardware, right? And what AWS did is AWS made it possible for startups, for any company in the world, to be able to build and deploy onto commodity hardware, which was much cheaper, which was elastic, which was ephemeral, which, like, you could go and do lots of different things. Through that lens, of course, we've enabled lots of innovation, lots of companies to go and build. But that was, in terms of innovation, that built a big industry, of course. But even back then, and knowing now, developer productivity and building tools for developers to use has always been a critical part of what we've built, right? The container ecosystem evolved to some degree as a result, or in some degree to take advantage of cloud computing, but it has evolved to run both on the cloud, on device, and everywhere else. It's used also for, in your development tool suite to be able to start services like running locally, starting Kafka or starting Postgres. Easiest way is to just do it with a Docker run command. So the same kind of elements that we had inside of AWS, democratizing commodity compute, in some ways, we're democratizing ability to use any kind of tool, any kind of library, any type of package that's available. Docker is enabling to do that.
So when you say using any kind of tool, any kind of library, any kind of package, you're talking about both open source and proprietary packages, right?
Containerization is used for both use cases. Of course, the vast majority of artifacts and the vast majority of things that are available on Docker Hub are open source, but people use the same mechanisms to distribute also commercial software. No reason why not.
Have you seen that? I know I've been wondering this. Have you seen more activity recently in the open source community from Windows on Snapdragon type PCs and developers? I know that, since we are right now Windows rather than Linux, that, hives off a certain part of the open source community. But in terms of people working on Windows, are you seeing more coming through with Windows on Snapdragon compatible projects?
So I'll talk maybe a little bit in general on Windows. An interesting part for us at Docker, and when people think about Docker, oftentimes people think about open source, because of course this is where a lot of open source projects live. But if we look at our user base overall at Docker, Windows represents more than half. Windows developers represent more than half of our user base overall. And that's, to me, coming to Docker, that was a surprising statistic, to be honest. And increasingly, we're seeing more and more users on Qualcomm devices and Snapdragon devices adopt as well. So it's an interesting kind of dynamic that we're seeing over here. And the Snapdragon ecosystem, of course, is growing as well.
Okay, great. So, shifting a little back to your backstory, because I think your backstory is fascinating. So you're based in Toronto, right? Is most of Docker in Toronto? Is Docker a very distributed company?
Docker is a remote first company. We actually do not have a physical office anymore, and people live in all parts of the world. In fact, on a daily basis, I interact with people from Europe, from West Coast, from Asia. Docker is a very distributed company nowadays.
That makes me, so how do you, just from a cultural perspective, I know this isn't a question you're prepared for, but now I'm just curious. From a cultural perspective, in a company like that, how do you prevent yourself from working like literally 24/7?
Oh, no.
No, you do work 24/7?
No, we don't. We actually, there's actually a good culture over here of trying to set boundaries. It is up to the individual to be able to set those boundaries. And to make sure that they take the time that they need. But it's ingrained in the DNA at this point of the company, is to be able to do that, and to be able to, most of communication is asynchronous, right? So sending messages and expecting a reply at some point. The expectation is people work hard, but the expectation is people also take time. It's oftentimes required to find time in various times of the day to connect with some colleagues, but it is what it is. There is a benefit to it as well, that I happen to live in a city I really like, and to be able to live next to the people I like. Sometimes I pay for it by jumping on planes, but that's the price of
Yeah,
doing the role.
sometimes we all pay for it with 11 p.m. calls. I definitely know how that is.
On occasion.
Do you find that fully remote aspect of Docker? Do you find it makes it easier to recruit? I feel like you get you get access to a really high quality of engineer that way, right?
You do, especially with our open source grassroots, and the fact that we get, like, a lot of times you get amazing candidates out of, pick a country, right? Any country, and they're amazing, not because they've been living in the community for a number of years and they've been contributing, and they happen to live in Spain, or they happen to live in Germany, or they happen to live in pick a country, and the value of that particular candidate is significant, is very significant for us. And then the place they live becomes just where they live. They're extremely valuable.
Great. So one of the things that, as you know, full disclosure to everyone listening, Ellie and I have spoken before. One of the things that, as you know, I find particularly fascinating about your backstory is the thing about the bus. And I wanted to make sure we talk about the bus before we get back to the technology. And by bus, I do not mean memory bus. I do not mean data bus. I do not mean 32-bit bus. I mean actual bus. Tell the bus story.
Earlier in my career, I was fascinated by transportation and ability to move people.
This is back in people.
Containerized, well, to a certain degree, yes. To a certain degree. This is back in the day, around the time Uber was starting. And what we saw, me and a couple of friends saw an opportunity to be able to go and innovate, see if we can help organize. We looked at public transportation in the city, and we saw a couple of unaddressed areas, and we said, let's see if we can build something. So we launched a bus service from one area of the city to another area of the city. As a true startup, basically no funding, got a few people interested, and launched service, and actually got a lot of publicity as a result. Also almost got sued, but that was a different part of the adventure.
So you had, at that point, you were already a tech guy. You were working with other tech guys. Were there, particular advanced technology aspects of this? Were you, tracking the vehicles, telemetry? I don't know what advanced technologies you use here.
At the time, the idea behind it was crowdsourcing. So, hey, can we get people to figure out where they live, major center of urban population, and areas where they work, where public transportation options were inconvenient? Can we crowdsource it and then launch it as a commuter kind of service for people to go get from one place to another? Little did we know at the time that the city has a legal monopoly on public transportation. Yeah, interesting times.
Yeah. No, I wonder.
I stuck around to developer tools after that.
Okay. So was there anything you learned through that process that you then took to your later work, in terms of learning from community suggestions, or in terms of the way you worked with the team, that you were able to take to this very community focused company that you're in now?
Yes, the most of the learnings for me were the ability to just, get stuff launched super quickly in the real world. We were able to launch that service literally within weeks, and we were able to get, once it became interesting, people became interested. But of course, working with the community, This was less of a technical community. This was overall the city and all of that. This was super early in my career. I've been around open source for quite some time. Before and after that, some lessons apply, some lessons don't apply. But it was an interesting journey.
So you definitely approve of ship as fast as you can, and then ship as fast as you can, and everyone can work the kinks out together later.
Correct. It doesn't. Yes, don't drive as fast as you can, especially on a bus and all of that. But ship it as fast as you can.
Okay, fair enough. So so getting back to Docker, and especially getting back to AI. One of the things that I've found people are having trouble figuring out is there seems to be like this really complex proliferation of AI tools and APIs out there right now. There are a lot of different proprietary APIs. There are a bunch of platform APIs. There are open source things like llama.cpp. How do you find people navigating their way through this, and how do you think the issue of on-device AI APIs is eventually going to shake out?
That's an interesting question. I think the way I see it most predominantly, I actually see it in a slightly different light. I see the community starting to cultivate around a couple of standards that are shaking up to be standards, but fairly quickly. So we've seen the OpenAI API becoming quite standard. Whether you're making requests to OpenAI or you're making requests to a local model, the underlying assumption is that you will be making a request towards an OpenAI compatible endpoint. We're also seeing standards
Llama and LM Studio both put out OpenAI API endpoints.
Same as Docker Model Runner that supports OpenAI based endpoint. Similarly, we're seeing MCP become a standard, right? So this is an explosion that we've seen over the last few months. We're seeing A2A and other standards emerge. So we're seeing quite a lot of those emerge as standard. We're seeing communities build around many open source projects. So Llama CPP, you've mentioned, VLLM, and many others. And we're trying to enable as many of those technologies and many of those communities as we can through the work that we're doing over here.
That actually goes to a question we're getting for our audience, which I think dovetails really well with this question, which is one of our viewers is saying, given that Onyx runtime already ensures model portability across platforms and devices, and I think for Onyx runtime, are we supposed to call it WinML now? Is that?
I can't keep up.
I know I can't keep up with Microsoft changing their names every 6 months. But yeah, so given that Onyx Runtime, or WinML, already ensures model portability across platforms and devices, especially edge devices, what additional benefits does using a Docker container provide in such scenarios, particularly when you're working with simpler lightweight models? And I think the answer may have to do with, what is, having a little bit of your project be portable as opposed to having your whole project be portable, right?
I think it's yes, that's one way of looking at it. Another way is how are you going to be? And a lot of times, our people that work with us, work with Docker, they run things on device, but those things end up running in production, right? Those things eventually end up running on maybe Windows, maybe Linux, maybe portability is a core value proposition of everything you do with Docker, and containers allow you to have that portability across the board. In some instances, you might be running an application just specifically for the Windows ecosystem, in which case maybe containers don't always make sense. But if you're trying to if you're trying to build an application that will run on multiple multiple architectures. If you're building on Windows, you're running on Linux. If you're trying to benefit from this ecosystem that exists, containerization makes a ton of sense.
And now, does that also, I'm genuinely curious, does that also work across architectures? Because I know that a lot of people are thinking about x86 versus what I like to call Windows on Snapdragon compatible, but other people have another term for it. Does containerization also help when transporting projects across architectures, or is there a hard break there of a sort?
There's no hard break. The reality that containerization supports multiple architectures, and you can build images for x84 or for as you called it.
You can call it what you want. You can call it what you want.
Yes, so you can build for any architecture, and in fact, we're seeing ARM64 come up quite a lot. People building for that architecture, and people are able to switch back and forth, especially if you're running on one device to another device. Mm-hmm. We're seeing those use cases come up quite often.
So, if we look a couple of years down the road, we've been talking this whole half an hour about people starting to experiment with on-device processing, and people starting to use on-device and hybrid AI processing versus the predominantly sort of vastly server-based approach that is common right now. If you look, say, 3 years down the road, and with the speed that things have been changing, I don't know if any of us can look 3 years down the road, so I will not hold you to this. If you look 3 years down the road, how much AI processing do you see going on device as opposed to in the cloud? And how do you see applications operating when they're trying to use AI, especially in an LLM or an unstructured data processing kind of way? Let's say, 3 years from now, when a bit more of this transformation has happened.
So I think giving exact percentages is difficult, and no one knows. But what I can tell you, that my prediction is that yes, there is going to be lots of growth, both on cloud-based inference and on device-based inference. And what we're seeing is a clear pattern of is that there is growth in both of those, and there is interest in the use cases starting to emerge. Sometimes someone wants to be able to run local inference because of latency issues, because they want to be able to do things super quickly, pre-process, post-process. We're seeing lots of different of those use cases, and I believe this will continue to expand. We will see more scenarios where even use cases that use the frontier models, right? When there is little connection, when there is bad connection, or where there is no connection, run on device on a model that has performance close to a frontier model. So I think what I expect to happen is I expect both to grow very significantly over time. And even now, the performance of some of the open source models starts to rival some of the performance of the frontier models. All of those things are moving super quickly, and predicting is quite difficult.
Yeah, though, as you say, like one of the things that encourages me, as you say, are these standards that we're converging to these common interface standards. If the OpenAI API is able to access both an online frontier model and your local model through Model Runner, you can have a relatively gentle fallback where you are trying to query the frontier model, but if you're out of credits, or you're out of connectivity, or your system judges that you don't necessarily need that, you fall back, and it's still the same structured query, but it's to a local model. And that's something I feel like I haven't seen that in production applications yet, but I feel like it's almost there, right?
I'm seeing a lot of signals that point in that direction. I'm
Okay.
seeing the ability to be able to support those quite frequently, talking to engineers.
Okay. Now, do you think that so do you think enterprise or consumer is going to be the first place where we see these kinds of applications breaking out? Think it'll be enterprise tools that create tools?
It's hard to say at this point. We're seeing those use cases emerge in both scenarios. In the enterprise, it could be driven by privacy concerns. It could be driven by geopolitical concerns. It could be driven by, hey, I do not want my data to travel across the wire
Mm-hmm.
to a place I do not control.
Mm-hmm.
We're seeing, individuals and hobbyists trying to do it for a variety of reasons as well. They want the performance of an on-device compute because they want possibly latency. They want something super fast. They want to be able to leverage those components for on-device process. So, like there's different scenarios that we see and different motivations that drive developers to adopt it in the enterprise versus what individuals do.
So you've mentioned, I mean, I understand as a Canadian why the geopolitical concerns are on your mind. The cover of New York Magazine this week says the Canadians are very, very angry. And are you seeing more? Have you been seeing activity in the sovereign AI space? Like, we've been talking about using frontier models and the concerns of developers in terms of using AI models that have what may be negative geopolitical implications for them. Do you see more activity globally? You're a global company, you have global developers. Do you see more activity globally in terms of creating more local or sovereign models to get around that issue?
The activity happens across the board. It's where the models are coming from. It's also where the inference happens. And it's as a space matures overall, and as both individuals, companies, and regulators start paying a lot more attention into the kinds of payloads that go across a wire, those concerns start coming up, and people start asking questions. And it doesn't have to do with like Canadians or not Canadians. It's a global trend that we're seeing across the board of how people think about the implications of this data traveling. For would you want medical records to be traveling across country lines? People start asking those questions because when you start looking into the payload that goes across the wire, it looks like magic on the screen. But when you start looking into the type of information and the amount of information, there's quite a lot there. So that's what drives, hey, how can we control it? How can we run inference in places where we know? All of those concerns start coming up. Who has access to this as well?
I'm also just fascinated in the world of I call it sovereign AI, but not all of these things are created by countries. In the world of international models, I'm also just fascinated by the cultural differences and the cultural impact. I wish I was more multilingual. I only speak English, unfortunately. But between how an Indian model trained on a vast amount of Hindi content, trained on a vast amount of India created content, would respond culturally or in a usability way compared to something that's generically sucked down the internet like ChatGPT, or compared to a Russian model or a Swedish model or a Saudi Arabian model that have been trained very focused on that culture's content. Have you checked out how any of those international models work? I haven't really.
So I've played around, of course, and I'm seeing quite a lot of differences in in how those models behave and what they're allowed or not allowed to say in particular circumstances.
Mm-hmm.
All of those, like we're seeing this come up, and we're seeing companies not necessarily also only in cultural ways, but also in fine tuning a model to be able to have domain expertise in a particular area, right? Which is important for a particular customer, is very critical. An ability to go and maybe have a smaller model that is capable of really going deep in a particular domain become very, very important. An ability to be able to run it and version it, the model itself, maybe independently of the rest of the code becoming important, right? What we're seeing is uh, people looking at this and like there's two types of disciplines emerging. There's a discipline of people who build applications with models, and
Mm-hmm.
there are people who produce models, and they want to be able to compose those and to be able to version each one of the components
Mm-hmm.
independently. So being able to, for example, have a refinement of the model done by the machine learning team, who now, something could have changed, the world changed, or they've improved the model, and they want to be able to continue to use a new model with the same application that was written, and is able to leverage that. An ability to compose those components becomes very important, right? So whether it is for, as you say, cultural differences, an ability to have a more culturally fine-tuned model in a particular market, or to have a model that has more domain expertise in a particular domain, we're seeing both of those come up, and companies come to us and ask for those types of use cases. And also what we're seeing is companies do not want necessarily to unlearn some of the lessons they've learned building with DevOps. How do we continue to have our existing tools that exist uh, in in CI/CD? How can we continue to test effectively what is going to go out to production? So all of those use cases come up, and we're be it for the models or being able to use those models as part of your existing application and existing workflow.
I love the idea of being able to rev or improve the functionality of your application, not necessarily by revving the application itself, but by improving the domain-specific model it's based on. And I know that at Qualcomm, we've talked about domain-specific models being one of the potential drivers for more on-device AI as they can tend to be smaller yet maintain high functionality for their domain. Are you seeing, so you're seeing customers and you're seeing players in the industry do this where they rev and improve the domain knowledge of the models to improve the functionality of their applications? And is this something that Docker makes easier?
We see it all the time. People build this one model and try to upgrade to a different model that just came up. People build with, people want to test. People want, like, all of those use cases are very core to what Docker enables people to do.
Mm-hmm.
And all of those use cases is something that we try to lean into through the tooling, the functionalities, the libraries that we enable. And this is what, to be frank, developers are super excited to talk to us about, because everyone understands that the models will continue to improve,
Mm-hmm.
whether it's the fine-tuned models or the available open source models. All of those are, the rate of change is going to continue accelerating in our mind. And we do see the model, the cycle of a model, the evolution of the model, to be separate than the evolution of the core application. And
Mm-hmm.
being able to build this both components and to be able to independently version those becomes a core important part of what developers want to be able to do and what companies are asking us to help support.
Okay. So just as we finish up here, I wanted to take one or two more questions from the crowd. And I see one question I can actually answer before we say goodbye. I'm sorry, fellow who wants the details of how models are implemented on edge devices. I would suggest that you go to our developer Discord and ask Rain and Nick, who are our developer advocates, who can point you to some detailed resources on that topic. And of course, everyone watching this should join our developer Discord. Hopefully, it's a vibrant community. The last question I see here is from someone asking to know the roadmap of Snapdragon chips. I'm sure many people around the world want to know the roadmap of Snapdragon chips, but that just lets me promote the fact that Snapdragon Summit is coming on September 23rd through 25th of this year. And while I'm promising nothing specifically, every year there have been new Snapdragon chips at Snapdragon Summit. So past performance does not guarantee future results, but it may be a pretty decent indicator. Ellie, thank you so much for coming online and having this great conversation about on-device AI. Is there anything you want to leave us with in terms of where people should go in terms of getting tools, in terms of getting support, especially if they're Windows on Snapdragon users and want to make sure that they're getting the appropriate version for their platform?
In our case, docker.com is the right place to go. If you navigate to docker.com, there is a download button that you can hit, and it will automatically detect the right version of Docker to download for your particular device. And if you're running on Windows and Snapdragon, you'll get the appropriate version. I'm available at Aleyner on X and other platforms. Happy to talk to people and happy to engage. Otherwise, there is all the regular communication channels that are available with Docker as well.
Great. And I am Sascha Segan on X, and I'm also available both on the Qualcomm Developer Discord and on the Snapdragon Insiders Discord, which is where you should go if you want to have a more consumer-oriented discussion with other Snapdragon fans about Snapdragon devices. So this has been the first episode of Constellation. Please join us next month for a conversation with Zach Supala, the CEO of Particle, a company with an innovative single board computer with onboard 5G based on Snapdragon. I think it's the only 5G enabled SBC out there. So I'm very excited to talk to Zach about the Particle Tachyon. This was a great conversation about AI and where it's going, Ellie, and I hope we'll get to talk again in the future.
Thank you for having me. It was exciting. Thank you.
Thanks a lot, folks.